All right, I guess I'm recording. So I guess I intend for this to be for you to ask me questions and me to answer them. And I'm in LSF 205 with the chalkboard behind me where I can do problems if you'd like me to do problems. So I'm all ears.
Well,
Make
I
sure
have a
you're
question.
unmuted. Yeah, go ahead.
Oh, I have a question about the format for right now. Starting
Okay.
off the test. So we have an hour to complete 25 questions. You said we could email the work to you. So with the test, are we just inputting the answer or like how? I don't understand. Like if we have to.
Okay, it's in Blackboard, so yeah, there's a box to put your answer, and if for a problem, for instance, you don't want to type it all out in that answer box, you can work on a piece of scratch paper and then get that to me over email, just like you do with the problems or something.
Okay.
Could you work problem number 28 from chapter 3?
28 from chapter 3. I will give it a shot, yes. I'm just over here looking at my book. Oh, the PKU problem, yes. So PKU is fetal ketonuria, a disease that results from a recessive gene. Suppose that two unaffected parents produce a child with PKU. So that means that the parents would have to each be heterozygous or carriers for it. So the parental genotypes would be, for instance, big A, little a, where the little a codes for the PKU disease. Okay, so what's the probability that a sperm from the father will contain a PKU allele? So in A, we use our formula P equals A over N. We want the little a allele, 1, and there's only 2 choices, one big A, one little a, so the answer has to be 1/2 or 50%. Do you guys see that okay? The board or not?
A little bit.
Okay. So I move the computer a little closer, will that help? Try that. This table's not moving. I don't know. Does that help more?
Yes, sir.
Okay. And holler if you can't see something or if I need to move the computer or whatever so you can see better, okay? I'll assume you can see okay unless you say otherwise. All right, for part B then, what's the probability that an egg from the mother will contain a PKU allele? So that's the mom's genotype. Again, A over N. A is 1 for the little a over 2 possibilities, big A or little a. So B is 1/2 as well, or 50%. C, what's the probability that their next child will have PKU? If we do a Punnett square, that's the best way to see this. So again, using our formula, A is 1, we want, or we're interested in little a individual there with PKU, and there's 1, 2, 3, 4 possibilities. So it's 1/4 or 25%. And then D, what's the probability that the next child will be homozygous for PKU? Did it say, wait, it said heterozygous for the gene. Okay, so that's, in this case, 1, 2 out of 4, which of course is the same as 1/2. There's 2 possibilities of getting a heterozygote. Okay, so that's how you do that. Any questions there? No? Not all muted, are you? Anybody have any other questions?
I have a question about problem 36 from chapter 5.
Ah, that one, yes. In that one, that's the one with the goats, right?
Mm-hmm.
The beards and all that. So the cross is the same, but what you have to do is interpret the results twice. Once for males because one trait is dominant and the other recessive, and then once again separately for females because the alleles are reversed in terms of dominance and recessive. Okay, but I can do some of that problem. Yeah, let me find it in the book. Yeah, also there was a typo in this problem too, where numbers A and B are, I can't remember what the typo was, but there was a typo with it. But anyway, let's do A, and I'll show you how to do that. I'm gonna have to erase this. So here we go. So here's the genotypes, males, females. Let's see, beard allele is B plus. Oh, B plus is beardless, okay, all right. So then we set up a Punnett square. And really the same thing goes down the side. So then we just fill it in now. Almost there. Okay. So there's all our genotypes. Now what we do is we go through here once and list things for males and then do the same thing for females. And let's see here. So remember in males, that is dominant, but for females, B plus is dominant. So this is the sex-influenced gene here. The other one for color is not, where big W is black and little w is white. So if we go through this, let's do the males here. I get that. Let me make sure I'm reading that correctly, the B's. Down to males, females, we use the symbol big B, beard, heel. B plus for the beardless allele. Okay, so. Beardless black, BL for beardless, second B for black. Beardless black. Bearded black, I'll just use the regular B for bearded. Here, also bearded black. Beardless black. Beardless white. Beardless black. Bearded white. Bearded black. Bearded black. Bearded black. Bearded black. Bearded black. Bearded white. Bearded black. And bearded white. So let's see. Now we count them up. And beardless black, 1, 2, 3, 4, 5. Right over here, can you see that? Or is that too far out way? I'll have to tilt it. How's that? Okay, again, this is for males. So 4/16 or 1/4 of the males are beardless black. Let's see, beardless white then, let's look at that. Some of those somewhere is right. One beardless black. There'll be one beardless white, excuse me. That might be it, I think. For bearded black, let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 8/16 are bearded black, and then bearded white. 1, 2, 3/16 bearded white. Is that it up all right? Yes. So That's what we would do, and then we would go back through it, with the same genotypes, but for females, we're going to assume that the B plus allele is now the dominant one and not the BB allele, okay? And so we'll get a different phenotypic ratio for the females and the males based on, though, the same genotypes, okay? Does that make sense?
So would we list two different, like one specifically for the males, one specifically
Yeah.
for females?
Right, and then and you just make another column for females, and remember the W's stay the same, big W, black dominant to little w, white, but now the B plus allele for beardless is dominant to the BB allele for bearded in females, right. So yeah, you do two columns. Yes. Does that make sense? Okay. I like those little emojis. I'm all ears if you have any other questions. Oh, number 37 from chapter 4? I'll give it a shot. Ah, that thing. Okay. Yeah. That's one like I did the last problem in the YouTube post where we have one sex-linked gene and one autosomal gene. So it's a dihybrid cross. Okay. So, and again, the proportions could be different by sex. It depends on the individual problem. But so, now the reason they're telling you all about the parents of these kids or these people is that so you'll be able to figure out their genotypes, okay? It's not just a bunch of stuff to confuse you. So anyway, we've got red-green color blindness, which is a X-linked recessive trait, and then polydactyly, which turns out to be an autosomal dominant trait. So Martha has normal fingers and toes and normal vision. Mother's normal in all respects, but her father's colorblind and polydactylous. So let's see. With regards to her X chromosomes, her sex chromosomes, her mother's normal, so she gets X plus from her mother, but her dad is colorblind, so she gets the XC for her dad. So remember, in these sex-linked traits, our allelic designations here are superscripts to the X chromosome. Okay. So Bill then is colorblind and polydactylous, but he is heterozygous with regards to the polydactyly because his one parent is not polydactylous. His mother is not. But let's see. Here's the part that there may be a typo in this thing. Let's see, Martha has normal fingers and toes, normal color vision. Her mother is normal in all respects, but her father's colorblind and polydactylous. Oh, well, her dad was probably heterozygous then. So she'd have to be little p then for her polydactyly genotype to have normal fingers and toes. So now from this, then we can construct a Punnett square. So fill on top, big P, little p, y, big P, y, little p, and then Martha, x. Oh, that's a little p, xc, little p. And I guess that's all, yeah, that's all the gametes she can make because she's homozygous for the polydactyly. And so over here will be the boys, here will be the girls. Okay, so that's our genotypes. Now we'll do things separately by sexes again. So then for the females, looks like 1/4 of the offspring will be, see, these would be polydactylous. The next ones would be totally normal. And these girls down here would be colorblind and polydactylous. And these would just be colorblind. Okay, so equal numbers there. And then if we look at the males, I do them down there. Can you see that okay? A 1/4 will be polydactylous. Normal vision there, but polydactyly allele. A 1/4 of the boys will be normal vision, no polydactyly. 1/4 will be colorblind and polydactylous. And then 1/4 will be just plain old colorblind. Just like me, I'm red-green colorblind also. So you end up this time with the same results in both sexes, but you don't necessarily, that won't necessarily happen all the time, okay? Can you see that okay? I need to get out of the way, don't I? Okay. Anything else?
Hi, can you go over 44 from chapter 8?
Well, that's not part of this exam, though.
Oh, okay.
So we can do that later. How's that? Because I think I've only got 40 minutes on Zoom. They're about to kick us off.
Okay, thank you.
Sure, yeah. Otherwise, I'd be glad to. But I think most people got it right. I just created those chapter 8 problems today, and most people got that one right, yeah. Yeah, so don't waste your time studying chapter 8 tonight, okay? That'll be on exam 2. Anything else? You got like 6 or 7 minutes left of our PowerPoint. Oh, saw something flash up there. Okay, the format again, 25 questions, most of them short answer, but there's I think 4 or 5 problems. And that's pretty much it. It's on Blackboard. So it gives you a box to type in your answer. And for problems, if you don't want to type it in, you can do it on scratch paper. Email me the scratch paper and just put the final answer in the box or something. And generally in this first exam, grades tend to be higher. I think we're starting with the simpler material, then we're going to work our way into the more complex stuff. So, the second exam scores are usually a bit lower than the first exam. So it's good to study hard and get a good grade on this first one so that the second one doesn't damage your grade in the class too badly. I guess if there's no more questions, then I'll end this thing. About to kick us off anyway, I believe. But feel free to email me if you've got any questions I didn't address here. Okay, going once, going twice. Good luck. And I was going to say I'll see you tomorrow, but I guess I won't be seeing you. But goodbye.